Alright, hi, welcome back guys. Today we'll be doing 1.9 through 1.10 rational functions. This is based off the AP Pre-Calculus curriculum of my classroom and what we have been doing. So take it as you wish, but I'll try to give you the gist of it. Okay, so we're going to start by creating rational functions from descriptions and graphs. So a rational function, r of x, has the following characteristics. Zeros at x equals 4, x equals 0, vertical asymptotes at x equals -8, and x equals -3. A 0 of x -3 in both the numerator and denominator. And the limit r of x equals -2 as x increases -infinity. So we know there may be multiple answers, but this is the one that I would give. We know zeros go at the top of the function. So we'll begin with r of x equals x minus 4. We know it's x minus 4 because the 4 we are given is positive. So when this is solved for, it'll become x equals 4. It all just goes back. Alright, and now we keep going. We know we have a 0 at x equals 0. So now we actually have to delete what we already have and put the x in front of this. Because x equals 0. X minus 4. Okay, and then we move on. And we know we have vertical asymptotes at x plus 8 and x plus 3. Alright, and we know vertical asymptotes go on the bottom. Alright, and then a 0 of x equals -3 in both the numerator and the denominator. Now, what we must see here is that zeros in vertical asymptotes are independent of each other, the same way that a vertical asymptote is independent of a horizontal. So we cannot count this 0 at x equals -3 in the numerator and the denominator as the vertical asymptote of x equals -3. So now we have to put another x plus 3 in the bottom. But in reality, that can just become, we can just put a square on top of our x plus 3 and then put an x plus 3 at the bottom. At the top, I mean. Alright? And now if we keep moving on, we see that there's a limit notation right here. And what it's telling us is that as x goes towards the left side without bound, so we're looking at a graph, as it goes this way without bound, it is stopping at -2, which means that is a horizontal asymptote. And what we know is that horizontal asymptotes are based off of our greatest leading coefficient on the x factors, like their leading coefficient exponent or whatever it's called. But basically, I am not your math teacher. If you have questions, go ask your math teacher. But basically, if it's reaching -2, that means that our leading coefficient has to be -2. And when we multiply these x's out, that's x plus x to the exponent of 3. And then at the bottom, we have x2 times x, which also gives us x to the exponent of 3. So we know that when these two are put above from each other, the horizontal asymptote equals y equals 1. But in reality, if you put a -2 in front of it, it'll equal, the x to the third power will cancel out and give you y equals -2. So our final answer is r of x equals x minus 4, x plus 3, -2, and then x plus 8, x plus 3 squared. Okay, so now we move on to the next problems. These are not in order too, by the way. I just pulled them out from our packets. So, writing an equation of a rational function with the following limit properties. So here we're giving limit f of x equals negative 3 as x approaches 2 to the left. We know it's to the left because the negative is in front of the 2. If it were like this, it would be as it approaches negative 2. But since it's over here, same as 2 plus, this would be left, and this would be right. Okay? So, okay. And then limit f of x equals negative 3 as x approaches 2 to the right. And then at the bottom, we have limit f of x equals negative infinity as x approaches 4 to the left. And then limit f of x equals positive infinity as x approaches 4 to the right. Okay. And we need to write an equation. Okay. So we start with f of x equals, we know that x, as x approaches 2 to the left, oh my god, it's negative 3. Technically, this can be considered a point on our graph. However, we can also tell that once it approaches 2, at x equals 2, negative 3, right here, it's a hole. Because on both left and right, it does not move from negative 3. So we know that is a hole. Okay? And now over here, at x, as it approaches 4 to the left, we know it's going negative infinity. And then as it goes 4 to the right, going positive infinity. We know this is a vertical asymptote because it would cross the line like this on x, and it goes negative infinity to positive infinity. So what we're looking at is something like this. And then it would have another one like this. We don't know where the horizontal asymptote is right now, but this is what we can figure out based on this. Okay? And then, so as this is 2, to the left of 2, it's negative 3, and then to the right, it's negative 3. And then the left of 4, our line segments are going down, which means they're approaching negative infinity. And then over here, they're going up, which means they're approaching positive infinity. Okay, so now we do the equation. We know we have a hole at x equals positive 2, so it would be minus 2, and x minus 2. And then we know we have a vertical asymptote at x equals 4, so it becomes x minus 4. But then, once we cancel this out, we are left with a hole at 2, and then we have to sub it in for x. So 2 minus 4 equals negative 2, and that isn't negative 3. Since we're given that specific point, we must write an equation based off that specific point. So something that will lead us to negative 3 would be a leading coefficient of 6 on top and negative 2 on bottom, which would then give us negative 3. So all that's left to do is write positive 6 next to our x minus 2. And this is our answer. Okay, moving on. Limit f of x equals 6 as x approaches negative 3 to the left. So now we are given both scenarios. We are given a negative number and the negative in front of it. And then limit f of x equals 6 as x approaches negative 3 to the right. And then limit f of x equals positive infinity as x approaches negative 1 to the left. And then limit f of x equals positive infinity as x approaches negative infinity to the right. Okay, same thing here. We're looking at a hole based on the specific point we are given. And we know vertical asymptotes don't have specific points. It's just a line through the x. And then here we have our vertical asymptotes. Okay, so we're going to write our function, which always starts with what we're given, equals. Okay, so we know there's a hole at x plus 3. So we need to put those to cancel out. And we know there's a vertical asymptote at x plus 1. Alright, so now when our x plus 3 cancels out, it gives us negative 3. But another key point before we begin this process is that both of our end behaviors are going up, which means that this equation is squared. And the reason it's squared is because it's happening twice. So you have 1 and you have 2, okay? Which means it's most likely like going something like this or something. I don't know. Like if we're not given a graph, I'm not going to worry about it. Just based off of my class. So then we cancel that out and we're given negative 3 plus 1, which gives us negative 2 squared, which is 4. And that's obviously not 6. So then 6 times 4 is 24. And then when you divide it by 4, we're given 6. So then our leading coefficient must be 24. So this is our final equation. Okay, moving on. For this equation, we will try to find the holes and the vertical asymptote. Okay, so we have a hole and then a BA. We know this is x equals, and we also know that this is x equals, but we will not be solving for the hole's exact point. We just want to know on what x they'll fall on. Okay, so we know they'll fall at positive 3 because this power overrules the bottom, which means it becomes a hole instead of a vertical asymptote. If there was a power of 3 down here, it would overrule the one above, so it would become a vertical asymptote, but that is not the case. And then we also must not forget this outside x, which cancels out and gives us x equals 0. So we also have a hole at x equals 0. And then we have a vertical asymptote at x equals negative 3. And that's it for that one. Okay, moving on. Write a left and right limit statement for the function as x approaches 3 for each of the following functions. Okay, so for each of the following functions, we can see x will approach positive 3 here, and it will approach positive 3 here to an extent. Okay, so g of x equals x plus 2 times x minus 1 over x minus 3. So I know x minus 3 in this case is a vertical asymptote. X equals positive 3. Okay, so the limit d of x equals x approaches 3 to the right, and then limit g of x equals as x approaches 3 to the left. Okay, one way to look at this is by drawing yourself a graph, and then this would be a positive 3, and then noting where the zeros would be. So we'd have a 0 and negative 2, and then at 1. And we know we have no horizontal asymptote because it's x to the power 2 over x. which equals a slant asymptote. But it isn't asking about that right now. What it's really asking is for the limit notation. So then, since there's no horizontal asymptote, there's no stopping us. And then we'll just go down. And over here, we'll just go up. So, as x approaches 3 to the right, it's going up. So it's positive infinity. And as x approaches 3 to the left, it's going down. So it's negative infinity. Those are your answers for that one. Then we move on to over here. We know we're looking for limit y equals, and then as x approaches 3 to the left, then the limit of y equals as x approaches 3 to the positive. Okay, we know this is a whole, so x equals 3. Now we plug it in. X plus 4 equals 7 over x plus 5, which is 8. So our whole is at 3, 7, 8. So it'd be like right here. And that's where it will be, both looking at the left of it and the right of it. Okay, moving on. Now we have multiple choice questions. We will be using the graph of the rational function y equals h of x, shown to the right, and then we had to use it to follow the following questions. The function h has a vertical asymptote at x equals -2, and then a horizontal asymptote at y equals 2, and a whole at x equals 1. And it's all shown right here. Okay, so we are being asked which of the following limit statements about h is correct. Okay, let's look at the first one. Limit h of x equals positive infinity as x approaches -2 to the left. So we'd be looking at our -2, which is right here, to the left. And is it approaching positive infinity? And we'd be looking at all left sides. Is it going up? Is it touching our positive infinity? Yes. We'll keep that in our back pocket for now. Let's check the other answers. Now it's asking us for the limit h of x equals positive infinity as x approaches -2 to the right side. Is it going up or is it going down? It's going down. So this one's actually wrong. Now it's saying the limit h of x equals -2 as x approaches negative infinity. And it's saying the same thing for both of them. And we can see that there's a horizontal asymptote at +2, not -2. So both of these are wrong, leaving us with A. So A was our right answer. Okay, this one is asking us for which limit statement about h is correct. Okay, so we look at the first one. The limit h of x equals +1 as we look at x approach 2 to the left. This would be saying there's a whole at 2, 1. And is there a whole at 2, 1? No. So this one's automatically wrong. Okay, limit h of x equals 0 as we look at x, which is 2, to the right side. Again, do we have a whole at 2, 0? No, so this one's wrong. Okay, C, limit h of x equals 2 as x approaches negative infinity. Okay, we're getting somewhere. So we're looking at our line segment right here. As it approaches negative infinity, is it approaching 2? Yeah. Okay, so we can keep that in our back pocket. And then the last one. Oh, it's another C. Okay, didn't see that one. Limit h of x equals positive 1 as x approaches positive infinity. This would mean there's a horizontal asymptote at 1, but it's at 2. So that one's wrong. So it's this C. Okay, which of the following limit statements about h is correct? Limit h of x equals positive infinity as x approaches negative 2 to infinity. Negative 2 to the right side. And we're looking at a vertical asymptote, and we know that one's wrong. We already crossed it off over here too, so we know that's wrong. Limit h of x equals negative 4/3 as x approaches 1 to the right. So we have a hole at negative 4/3. Is that true? Would you say this is 1? Negative 4/3? Yeah, I see that being a possibility. So we'll keep that in our back pocket. What about limit h of x equals negative 2 as x approaches positive 1? So we have a hole at negative 2. Are we touching negative 2? Not really. So this one's wrong. And then another C, limit h of x equals 3 as x approaches infinity. So we'd be looking at a horizontal asymptote, but we already established that our horizontal asymptote was at 2. So this one's wrong, leaving us with B. And then which of the following could be the equation for h of x? So we know there's a vertical asymptote at x equals negative 2. So A and C cross out because this would give us a vertical asymptote of positive 2. And then we know there is a hole at x equals 1. So B crosses out because this would give us a hole at x equals -1, leaving us with D. And that's it for today. Thank you guys.